Hey everybody, as promised, today we're going to do the second part of the fundamental theorem of calculus. It was not in the stuff that I had from the Flamingo math person, so I found another thing that did all the examples I would need for it to do. I just have to zoom in. I have it, I gave it to you guys also in Teams, but I have to zoom in. So hopefully this will work okay. Hopefully it holds the zoom without getting fuzzy or anything. But how it works is if the function is continuous from a to b, I'm starting down here in the middle of the page. I'm not worried about the top. And a is less than or equal to x, which is less than or equal to b. Then if you take the derivative of the integral from a to x, that's what's different, is that you might have a variable up here of f of t dt, it will equal f of x, which means you just plug the x in. It doesn't matter what this number is. You'll just plug in the x. And there's other stuff that goes with this, but that's a good starting point. So let's look at this function here. G of x equals the integral from 1 to x of cosine t squared plus 1 dt. So for this one, we just have to plug in x if we're going to do the derivative of g of x. So dg over dx, then the derivative, you're just basically undoing the antiderivative by plugging in x, would be the cosine of x squared plus 1. And you don't need to do plus c because it's a definite integral. You're technically plugging them both in. So that's it. That's your answer. Same thing over here on h of x. H of x you have from -3 to x. The number doesn't matter. It's from some number to x. So dh over dx would equal the square root of x squared plus 2x plus 3. That's it. That's your answer. Now the next one's a little bit different. Notice on these two, the x was on the top for both of them. It went from some number to x. This next one, the capital F of x, the x is in the denominator. So we're going to have to switch that first. We want the x to be on top. So remember when you flip it, you just throw in a negative. So negative integral from 0 to x of t to the 6th minus 2t plus 1 dt. Now it's how I want it to be. Now I can do the derivative. So df over dx would equal negative. We can distribute it or just put in parentheses, but negative x to the 6th minus 2x plus 1. Like I said, you can distribute that through. Negative x to the 6th plus 2x minus 1. And that's your answer. Not too bad. The next one, we have the same thing going on with our x in the denominator again. So we want to move it to the top. So we're going to flip it and throw the negative in the front. So j of u, now we have u instead of x though, is negative integral from 2 to u of t squared sine of t dt. And we're going to find dj over, and it's du because we have a u in our as our variable instead, will be negative, plug the u in here, so u squared, and plug it in here, times the sine of u. And that's your answer. Alright, not too bad. So the next page starts with some chain rule. So suppose that we wish to find the derivative of capital F of x equals this integral from 0 to x squared of sine of t to the fourth. You're going to have to use the chain rule. So you have a function up here. Your function is x squared. So what you're going to end up having to do is, this is the new part here. Like if that's your g of x, because that's your function inside a function, you're going to have to multiply times the derivative of this. So we're going to have a 2x at the end. So that's basically what you do. So here they plugged it in. So they had this, let's see, they like to show the derivative step. So you're going to have a sine, I want to go to here. So you're going to have 2x, that's the derivative of x squared. And then the sine of, then they plugged in the x squared and made it to the fourth, so x squared to the fourth. So it would be 2x sine of x to the eighth. Alright, so let's see what we have going on here. Hopefully I can fit this in this box. We have 0 to square root of x of all that. So I'm going to make that x to the 1/2. And then of t squared cosine squared of t dt. Alright, so we're going to do the same thing. We're going to throw in the square root. We just have to also throw in the derivative of x to the 1/2. You could even do that first. So dh over dx equals, derivative of this would be 1/2 x to the negative 1/2. Now we do the rest the same. Replace t with the square root of x. It'll be squared. And then you have cosine squared of the square root of x. So that this x could go in the, well, let's see, we can actually put those together. So we'd have 1/2 x to the negative 1/2, and then this would be x to the 1 cosine squared of radical x. So that's 1/2 x to the 1/2 cosine squared of the square root of x. And you could just write it neater. I'll squeeze it in there. Square root, or 1/2 square root of x cosine squared of radical x. Remember that squared is the whole cosine being squared. So it's not just the radical x. So it can't undo that square root. So that's the best answer. Alright, the next one, I'm going to go to the side real quick. Because you got x squared natural log of x. That's a little bit more complicated. That's going to require a little bit of chain rule, actually, or product rule. So x squared natural log of x, that would be 2x natural log of x plus x squared, and then the natural log of x is 1 over x. So that actually would just be x. So 2x natural log of x plus x. Okay, so we gotta multiply times that. So we'll keep that in mind. Oops, sorry, I didn't mean to cut it off. So I did product rule because we have x squared and natural log of x. I'm going to plug that whole chunk in for there and then multiply it times that derivative. The derivative of the x squared natural log of x. So dj dx will equal 1 over 1 plus, and it'll be x squared natural log of x to the 4th power, and then times 2x natural log of x plus x. There's not a whole lot you can do to make that pretty. Oh dang it, I forgot to move it over. There's not a whole lot you can do to make that pretty. All I did, sorry, I'll do it again here. I just plugged the x squared natural log of x in for t. So you have 1 plus x squared natural log of x to the 4th power, and then times that derivative that we had found over here in orange. So we can make it a little prettier throwing this on top. 2x natural log of x plus x all over 1 plus, and then it'll be x to the 8th times the natural log of x to the 4th. But that's about as neat as you're getting for the derivative of that integral. Okay, on the bottom, you have two x's, or two variables here. So like on ours, we have this example, we're going from x to x squared. You're going to use this concept where you just throw something in the middle. Our c will just make it be 0, because remember, it doesn't matter what your variable is. So we'll just throw a 0 in there, but you got to split it apart. So before we do anything, we're going to make this, we're going to go from x to 0 of e to the negative t squared dt plus 0 to x squared e to the negative t squared dt. Okay. Now, the derivative of x is easy, derivative of that's easy. So we can go ahead, we're ready. Let's plug in. So this, oh, just kidding, we're not ready. This x is not on top. Let me flip that. So negative, and then 0 to x, e to the negative t squared dt, plus, and then this one's fine the way it is, 0 to x squared, e to the negative t squared dt. Okay, so this will be negative. Derivative of x is just 1, so we don't have to worry about that for this one. E to the negative x squared plus derivative of x squared, that's 2x, and then e to the negative x squared x squared squared, so e to the 4th. So negative e to the negative x squared plus 2x e negative x to the 4th. That negative is not getting squared or to the 4th. It's like having a negative 1 in the front. So that's the simplest answer you can have for that one. All right, and then the last one, we got to deal with the square root again, which they're not that bad. We have square root of u. Oops, I probably should have wrote this better. I should have noted, like, these are not all equivalent to g of x. This is the step where we did dg over dx. I should note that properly. Okay, now this last one. Again, I'm going to split it using the 0. So this is still r of u. We haven't actually taken the derivative yet. Equals the integral from the square root of u to 0. Now this is the variable being squared, not the sine function. Plus, and then our integral from 0 to u cubed of sine of t squared dt. Okay, so I know that's u to the 1/2. I'm not going to rewrite it. So I'm going to go, I'm ready to take, oh, not ready. That's got to go to the top, dang it. So equals negative. I'll go ahead and rewrite it. 0 and then u to the 1/2 sine of t squared dt plus 0 u to the 3rd sine of t squared dt. All right, now I'm ready. So now we're ready to find the derivative of our antiderivative. So we're doing dr over du for this one because our variable will be u equals negative. This will be 1/2 u to the negative 1/2. And then we have the sine of, all right, this will be radical u squared plus, now the u to the third, our derivative there is 3u squared. Then we have sine of u to the third being squared. Okay, I think we're good. All right, I'm going to move this to the denominator because I don't see it being combined with anything else. So negative 1 over 2, and I'll go ahead and make it square root of u. Sine, and then square root being squared, that'll just become u. Plus 3u squared sine of u to the 6th. And that's our answer. All right, I hope this helps. You guys have a circuit to do, so I hope you're excited. But I liked it because it included the whole fundamental theorem of calculus. You have to do these and when there's a number on both. So you have to pay attention, which, sorry, it's good for you. I hope you enjoy it, and I will talk to you about the circuit tomorrow. Have a great day. Be safe.